Okay, I just wanted to try to talk to you about histograms, basically what they're for and how to create them in Excel. Okay, so what you see here is one that I've created in Excel. Basically, that is what we'd aim to create. By the end of this, you should be able to do the same. Okay, so basically what I want to do is just run through what they're about, why we use them, and I suppose how to construct them. So really, I think I talked about a little bit earlier, was that the difference between a histogram and a column graph is really about what is on this bottom axis. Okay, so where it's numbers, in this case, I'll explain a bit more about it, but in this case there are numbers at the bottom, then that we would use a histogram. What I want you to understand, I suppose, is that this is really a population, and these are different parts of the population that are ranked by their values. Okay, so basically this section of the population has lower scores than this section, which is slightly higher, this section. So it's a continuous population. Okay, and that's why that there are no gaps in between each of the columns. Okay, I'll talk to you about some rules later, but that is one of the rules that happens with histograms. Well, column graphs, they have different parts of the population, but they are different categories, and there's no ranking, there's no order for them. So they're not something that has to be presented continuously, so there's gaps in between. Okay, so basically we've got that sort of basics under control. I wanted to try to talk to you. There's two types of histograms. Okay, there's types where each of these bars represents a range of values, and they're sometimes called class intervals or bins, and they can be the range can be one or many units. So it's usually more when it's a bin. Sometimes they can just represent a single value. And how we determine that, there's a good rule of thumb that we really try to aim to have 5 to 10 of these bars when we're creating a histogram. Okay, now if there's just very slightly over 10, that's not going to be a problem. But what have we got here? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Okay, now some people say 5 to 15, but just as a guide, that's how many you would aim to have, and that would give you a good idea about then how to group data. So some data needs to be grouped. Well, I said it's about numerical data. When you've got a lot of different options for numbers, so if you were measuring people's heights to the nearest centimetre, and you had 100 different measurements, chances are that you're going to have to group them into, say, 5 or 10 centimetre bins. Okay, so because you won't really, well, you're going to have a lot of different answers because there's not going to be very many people that have the same height. They're all going to be likely to vary, and I suppose the other thing is that some people will not be a full centimetre. So if you didn't actually measure and round it to the nearest centimetre, there's going to be a continual nature of the data. So that's another reason why we'd have to group it in that case. So where there's lots of data that we've got too many bars, that would be one reason, and the other is about the numbers that we've got. So lots of numbers, or the numbers are not always whole numbers. Okay, so that would be another reason to group. Okay, so basically what I want to try to do is just go through the rules. Okay, so when we're doing the same as any graph, when we're doing a histogram, yeah, this is not a very good label, we'll do better than that when we get to it, but they need to have a graph label or histogram label at the top, a main one, so a title, and also we need to have two axis titles, axis titles, okay, one for each axis, and labels for each of these that are evenly distributed. Okay. One other thing that makes it a bit unique is that we have to have a half column width space before and after the histogram. And I suppose one other rule, which is subject to some debate, is some people think that they can't be shaded, the columns in this. I don't have a problem with shading as long as the shading is all one colour. That's what I've been brought up with. but I've actually gone with no shading in these because I thought that satisfies both of those rules effectively. The only other thing is that there's a convention for labelling here. So in the case of when we group data into bins, basically we will put a mid value for that bin. So this value, it's usually called, well, there's a few names for it, but basically it's usually called a class center or a class interval center, and that's presented in the middle of that bar. So really what this basically represents is from 5.01, so just over 5, not including the number 5, right up to and including 7. So if we only dealt with whole numbers, it would only get 6 and 7 that would be allocated to this section. If we were counting frequency, so scores of 6 and 7 would go here. Now basically this is halfway between 5.01 and 7. Now technically it would be 6.005, but I've rounded it. Okay. Now there are other cases where there are just values, and I'll see if I can just find a sheet here that you might have something. Okay, you can see at the top it's only very small. I'll just enlarge it. It's something that I was just working on before. Basically, each one of these columns is represented by a single value. Okay, and that's presented in the middle. So it's slightly different, but in terms of it's still in the middle, and that's okay. So in a way that's easier, and you'll notice that it all gets back to how many columns we have and whether it's worth putting them together in bins. Okay, so that's one that I just started with and I was experimenting with. Okay, so what I think we should do is we should try to get into some data and see about how to make a histogram for ourselves. Okay, so this is the numeracy data. So when we look at the three numeracy areas, this is all of numeracy's data. Okay, at the bottom, we constructed a sum column. So what I will do is I'm going to take those sums for each student of how many correct answers they obtained or achieved. I'm going to copy that, and I'll start a new sheet. Now what I'll do is I'll just work at the top of this sheet. Okay, so now because that was a sum, there's a formula, so I right click it and do paste special. I have to use values because it's a formula. Now it just got ahead of itself there. And I also want to transpose it, so I want it to run instead of left to right, from top to bottom. Okay, so that's our set of data now that we will be putting into a histogram. Now I always like to just have a bit of a look at the data, and I think the best, well, there's a few things that are nice to do, and one I would do is sort that data from smallest to largest. Okay, that basically gives us a few important things. So we know the lowest value, we also know the highest value, and that's important because when we're making a histogram, we have to put it into bins, even if the values are every value. So even if it's 7, 8, 9, 10, 11, 12, 13, right up to the highest value, we still have to write those down. Now in this case, we have a range that is from 7 up to 27. So what I would suggest is we don't want to have too many of those columns. So we'll try to go with an interval range that has sort of about 10. So I think what we'll do is just run with every second number. So first, when we're working with Excel, there's a little trick. Your second bin is always the lowest value. Okay? We'll put a number lower than that. We're going to jump into now, because there's not many, it's probably easier to do it manually than to use formally. Okay, now, and that's the highest value, and that's what we'll stop. Okay, so now the next thing would be to actually start trying to make one. Now, I'm in the data tab. This data analysis tab is the one we need. Now, some people may not have that data analysis tab. So what I would say is if you do not see a tab here, such as a data analysis tab, that you can add it pretty easily. If you go into, click this Windows button up the top, and you go and click Excel options. You go to add-ins, and you put go here. We'll give you a choice and you choose Analysis Toolpack. Okay. If you press OK, then it will prompt you to just install an add-on, and that add-on basically provides you with this tab. Okay, so once we have that tab, it's a case of just clicking Data Analysis. Now we've got our data and our bins set up. It's already on histogram, but you may have to go and search for it. Click it on and press OK. Now basically now what it is asking is prompting me, well, it's asking me to enter a range of values. So for our data, okay, so that's the data range. Then this one below is our bin range. Okay, now I'll just pop up again with the bin range. Highlight that after I've clicked in it. Okay, now this part here is just where a little table will be presented. Now the table isn't really that interesting to us because it's not in a very good format, but it is a crude version of a frequency table, which is another way of summarizing what is happening with the different groups within that population. Okay, so our output, we will just click a cell that's just adjacent, then that table will appear there, and we also want to make sure that chart output's selected and press OK. Okay, now straight away it's given us a histogram for that. Okay, so it didn't take very long. What I would suggest is the first thing is that we should enlarge this just a little bit. Now we will probably have another go at enlarging it later. So there's a couple of things that I want to attend to straight away. You will notice that the first bin has no entries in it. Okay, that was intentionally included, and basically I will remove those from that table. It also makes it disappear from the histogram. Same with more. It adds more in Excel. We don't want that, so we can get rid of those two, and now we're starting to get somewhere. Okay, so now the next thing, well, there's a few things to do with this. The first thing I'll do is right click on one of the columns, and we can format data series. The first thing is we want to get rid of the gaps, because that's what is one of the fundamental things that makes it obviously a histogram. Okay, so that's one of the important rules. Also with fill, we select no fill, and therefore we'll have to make it a very clear border, so we'll have a solid line and make sure that you select black so it's clear. Okay, now it's vastly changed very quickly. Okay, now the other thing is to select these data labels down the bottom. The box will be selected, right click it, and do format axis. Okay, now axis options, one that we will do is on tick marks. And at this stage I don't think that we will have to do anything. If we encounter any little minor problems, depending on our histogram, we might have to go back in there, but that's not usually the case. Okay, so I'll just press close for that. Now, obviously we'll have to fix up the titles of the graph and the axis. So just remove the legend or key. And now we're getting a lot closer to having something which looks like a finished product. Okay, now I think we might just start to label this. So we'll improve the title. And distribution of we'll put distribution of numeracy scores. Okay, now number of correct answers, and for frequency, this is about number of students. That scored that particular score. Okay, now really we're just getting down to the nitty-gritty now. We've got our half spaces, we've got no gaps in between, we have our titles. So we really have a large amount of this done. We're very close to completion. Now there's one thing that we have to fix up, and that is with our bins. Okay, so when we do an editing in this, it will show up in our graph. So really what I want people to do is I want you to look at this data, and I'll try to explain what's happening. So with the bins, when it is like that in Excel, if we write 7 is the bin, basically what it is considering is that 7 and 8 are counted. So there is a count for 7 and 8. Okay, but we really need to have it a little bit clearer. So we'll have to put a more accurate class interval in. Now I've done this down below. Oh, it was in sheet 11 I did it. I thought I just had one pasted before. I must have removed it. Okay, this histogram. So you can see that 6.01 was the middle of that class interval. Okay. So if we go back here, we know that there is one value here because there's one student that fell into this bin range. Okay, there's one student that fell into the next bin range, which is only one number 9. Okay, so that means that 10 and 11 both fall into the next bin. Okay, so there's a score of 4. So we know for 10 and 11 to fall in that bin that it must range from 9.01 here up to exactly 11. Okay, so this must be 7.01 right up to 9. Basically, if you are a little confused by that, the general rule is to reduce this down. If we've got two numbers in there, so it's a range of 2 where the bins jump by 2s, we would make this go down just lower than 1. So we can't make it go down 1 because it would be 6, so we make it a number that represents just above 6, and we would use 6.01. And then we'll jump up by 2s, so 8.01, 10.01. And they are the class intervals. So previously, what was showing was the upper limit for each of those intervals. And that's how Excel operates. So really it's just a case of going down almost one whole value and just trying to put some very small increment above that. So when I've got 100th above those numbers, that's achieved our objective. So it's really saying that this bin ranges from, well, the middle of it is 6.01, so it ranges from 5.01 up to and including 7. Then the next bin is 7.01 up to including 9. So if we only have whole numbers, this one will only have 6 and 7 included in it. This one will only have 7 and 8 included in it. I mean 8 and 9 included, sorry. This one will only have 10 and 11 included in it because it starts at just above 9, 9.01. 6.01. Okay, so that is something, but the rule is just move it down so that it is just slightly above the whole number. Okay, and I've just chosen 100th as an arbitrary way of representing just above that whole number. Okay, now that should look very close to what I had in the other one. Now what I would say is there's one other thing that we could do, and it's not very standard, but I think it's something that we probably do in this type of example. Is to also present a percentage. Okay, now it's very rare that you will see something like this, but I think it's just clearer, so then a comparison can be made. Okay, so really we've got a lot of information. We can see the spread of the population. And if we put percentage numbers in, we can also relate them to each other a little more. So where there's different numeracy areas, we can relate them. Okay, so in the case of this value, we need to do a calculation to work out what that represents as a percentage. So we're only going to go with the middle value. So it's 6.01. For all intensive purposes, we're not going to be able to present it accurate enough because we really have to only do it to the nearest whole percent. So if we work out 6 divided by 35, which is the number of questions, that will show us that it's rounded. We could round that to 17%. Okay, 0.17. If you're a little concerned about that, I'm going to show you if we multiply by 100, that will give us a percentage. Okay, so 17.1%. What we do is go to that bin, we press F2, and that lets us edit. Press the spacebar once, do a bracket, and then do 17%, and close the bracket. And then we press enter, and you'll see that it shows up down here. Okay, so basically that's something that we can do to make grouped data for histogram, and it also, the percentage thing is not always required, but I think it will be useful in this situation because we'll be able to relate to different numeracy areas in terms of what the spread ranges from and things like that. And also it'll be helpful because usually when you're dealing with things, you like to have not just a crude number of answers that were correct, but it would be nice to have a good understanding in terms of percentage of correct answers. Okay, so I think that should do us for this video. I will probably make one for just single values, but really the same rules apply. It's just a lot less complicated because we don't have to do these odd numbers. We just do our bins as whole numbers, and it's just a single number, and we go up by ones instead of jumping with 2 and having bins. So it's actually probably a lot easier. So I'd suggest that you have a go at, maybe for the smaller ones, doing it just as every whole number, ranging from one number lower than the lowest number here, so when we do our list, and going right up to the highest number in your list of values. And then when it comes to here, we can delete the one that's lower than the lowest value here and remove more, and then you'll have this as well. Okay, so I think that should do. So yeah, try to go ahead with that and the other types with the smaller numerous areas, and see how you go.